There are perfect circles in space, 1,000,000 light-years across, 10 times wider than our entire galaxy, and you cannot see them. No optical telescope can detect them, no infrared camera picks them up, no X-ray observatory finds anything. They're completely invisible to every wavelength of light except one. Turn on a radio telescope and suddenly they appear. Enormous glowing rings surrounding distant galaxies like cosmic halos. Astronomers call them ORCs, odd radio circles, and until 2 weeks ago, we had no idea what they were. 2019, Australian Square Kilometre Array Pathfinder, ASKAP for short, a field of 36 radio dishes in the remote Australian outback scanning the sky for sources of radio waves. The telescope picks up something strange, a perfect circle of radio emission, bright around the edges, fainter in the middle, with a galaxy sitting right at its center. The team checks for errors. Telescope malfunction? No. Atmospheric interference? No. The circle is real. Then they find another one, then another, each one enormous, hundreds of thousands of light-years across, each one perfectly circular, each one centered on a distant galaxy. Lead astronomer Ray Norris said, quote, "It's a completely unexpected discovery, not predicted by the physics we already know, and therefore revealing a gap in our knowledge," end quote. They named them ORCs, odd radio circles, because nobody knows what else to call them. Here's what makes them truly bizarre. As of October 2025, only 8 such objects have been confirmed, with possibly 6 more candidates. That's it. In the entire observable universe containing trillions of galaxies, we've found fewer than a dozen of these things. And they're only visible at radio wavelengths, completely invisible at visible, infrared, or X-ray wavelengths. Until now. For 5 years, astronomers debated what could create these ghost rings. Theory 1, supernova remnants. When massive stars explode, they sometimes leave expanding shells of gas that emit radio waves. But the math doesn't work. ORCs are too large, too faint, and too far away to be supernovae in our galaxy. Theory 2, black hole jets. Supermassive black holes can blast jets of material in opposite directions, creating radio lobes. But ORCs are perfectly circular, not bipolar, and they don't have the characteristic jet structure. Theory 3, Einstein rings, gravitational lensing. But that would require a massive galaxy cluster directly between us and a background radio source, perfectly aligned. The odds are astronomical, and we've found too many ORCs for this to explain all of them. Most astronomers believe ORCs are large, distant objects with a galaxy at their center. But what process creates a radio ring 1,000,000 light-years wide? Then, in December 2024, everything changed. 2 new discoveries published just 2 weeks apart finally cracked the case. January 2024. UC San Diego astronomer Allison Coyle and her team point the Keck Observatory at ORC-4, the only odd radio circle visible from the northern hemisphere. They're not looking at radio waves, they're looking at optical light using a spectrometer, breaking the light into its component wavelengths to see what elements are present. What they find is shocking. An insane amount of O2 emission, fluorescent oxygen ions, way more than there is normally, 10 times as bright as a typical galaxy. O2 emission happens when ultraviolet light from young, hot stars ionizes oxygen in surrounding gas clouds. It's a signature of star formation. But this much? It doesn't make sense. Unless. The team runs simulations. They discover that if a galaxy experiences an intense starburst, a period where millions of stars form nearly simultaneously, and then those stars explode as supernovae all at once, the combined stellar winds would be catastrophic. Winds reaching 4.5 million miles per hour, 5,000 times faster than a bullet, blasting outward from the galaxy. When that wind hits the thin gas outside the galaxy, it creates a shock wave that grows to enormous size over 1 billion years. Inside that shock wave, electrons spiral around magnetic field lines, producing synchrotron radiation, the radio waves we see as ORCs. The galaxy at the center of ORC4, its stars are around 6 billion years old, meaning a burst of intense star formation happened and ended around 1 billion years ago. We're seeing the aftermath, the ghost of a galactic explosion that happened when Earth's oceans had just begun to host complex life. Published in Nature, January 2024, The Mystery of ORCs, partially solved. But one piece was still missing. If ORCs are shock waves, they should heat the gas they're moving through. That gas should emit X-rays. April 2024, XMM Newton X-ray telescope observes the cloverleaf ORC, one of the nearest ORCs to Earth. For the first time, astronomers detect X-rays associated with an ORC. Hot, excited gas sitting perpendicular to the radio emission, exactly where the shock wave should be. Lead researcher Ezra Bulbul said, quote, "This is the first time anyone has seen X-ray emission associated with an ORC. It was the missing key to unlock the secret of the cloverleaf's formation." End quote. But there's a twist. Galaxy mergers alone can't explain the cloverleaf. Mergers happen constantly, but ORCs are rare. There's something special going on. The theory: ORCs require a two-part origin, powerful emissions from active supermassive black holes, followed by galaxy merger shock waves that give those emissions a second kick. First, the supermassive black hole goes through a period of extreme activity, accelerating electrons to high energies. Then, the galaxy merges with another galaxy, creating shock waves that re-accelerate those relic electrons. The result? An ORC. It's a perfect storm. Two violent cosmic events perfectly timed, creating a radio ghost that lasts 1 billion years. December 2024, 2 weeks ago. Meerkat Radio Telescope in South Africa discovers a new ORC. ORC J0219-0505. It's 371,600 light-years wide and has features that set it apart from other ORCs. It appears fainter and leans to one side. Ray Norris, the astronomer who first coined the term ORC, said, quote, "It's a completely unexpected discovery, not predicted by the physics we already know, and therefore revealing a gap in our knowledge." End quote. Then October 2025, the most powerful ORC ever discovered. RAD J131346.9 plus 500320. Found by citizen scientists using the RAD at Home Astronomy Collaboratory. It's not just one ring, it's two, interlocked like a Venn diagram. And it's the most distant and powerful ORC found to date. This double ring structure suggests something even more violent. Instead of simple galactic winds, researchers propose it may have been shaped by superwinds flowing from spiral galaxies. We're still learning. Every new ORC reveals something different. Some are faint, some are bright, some are single rings, some are doubles. Each one is a fossil of a cosmic catastrophe we're only beginning to understand.
Think about what an ORC represents. A galaxy undergoes a violent starburst. Millions of stars are born, live, and die in a geological instant. Their combined death scream, a wind moving at millions of miles per hour, blasts outward into the void. That wind keeps expanding for 1 billion years, long after the galaxy has gone quiet, long after the stars that caused it have burned out. The shock wave persists, glowing faintly in radio light. A ghost, a scar, a monument to an ancient cataclysm. And they're everywhere. We just couldn't see them until 2019. Alison Coyle said, "It's pretty rare to discover a new class of extragalactic objects, but we're still encountering new mysteries because of all the new data we're getting." How many ORCs are out there? Hundreds? Thousands? Will our own Milky Way create one someday? The universe is more violent, more dynamic, more alive than we ever imagined. And floating through it, invisible to human eyes, are these perfect circles, 10 times wider than galaxies, whispering stories of explosions that happened before humans existed. We're learning to listen.